Okay, so now that you know how to do one-step mole calculations using moles and converting into particles, or going from particles to moles, or from moles to mass using the molar mass, or vice versa, or moles to volume, those are all one-step problems. Now we're going to learn how to do two-step problems. And a two-step problem is just like stringing two of those one-step problems together with using moles in the middle. Let me give an example of graphically what we can do here. So the key to this is that we have in the middle of these calculations, we have moles. And we are going to be able to go from one measurement to moles, or from moles to one measurement, by using these conversion factors that we've learned. So for example, if I want to go to number of particles, from moles to number of particles, well, what do I use there? I use Avogadro's number, right? 6.02 times 10 to the 23rd. If I want to go from moles to grams of a substance, or from grams to moles, how do I do that? Well, I use the molar mass, which I can look up or calculate. And if I want to go from moles to liters of a gas at standard temperature and pressure, how do I do that? Well, I use the 22.4 liters per mole. Okay, so I've got this nice little chart, and I can figure out, well, if I'm starting at moles and I want to go up here, I use the molar mass. If I'm starting at moles and I want to go down here, I use Avogadro's number. But what if I'm starting up here at grams and I want to go down here to particles? Well, I can do this first step using molar mass, and I can do this second step using Avogadro's number. All right, let's do an example of that. So let's say I want to know how many atoms of aluminum have a mass of 50.0 grams. Okay? Now, nowhere in this problem do you see the word moles. That means that we're not stopping or ending at moles. We're not starting at moles, we're not ending at moles. But we are going to go through moles in the middle. What are we starting with? Well, we're starting with grams. That's where we're starting. What are we going to? Well, we're going to particles. We're going to atoms. Okay? So this is going to require kind of a double section that looks like this. Okay? And up here, we always put the thing that we're starting with, which in this case is 50.0 grams. Okay? And because I'm trying to get rid of grams, I'm going to put grams down here. Now, back on my little chart, if you look back in your notes, if you copy that chart down, the first place I have to go is moles. And the way I go to moles is molar mass. Now, the molar mass of aluminum, according to the periodic table, is 27.0 grams per mole. Okay? Well, there's my grams down there. So 27.0 grams, and that's equal to 1 mole of aluminum. Grams cancels. Now, I don't want moles in my answer. Nowhere in this problem does it mention moles, so I have to put moles down here so that I can cancel them out. What I do want is atoms, and the word atoms means I'm going to need Avogadro's number. Avogadro's number is 6.02 times 10 to the 23rd atoms per mole. Okay? So now, how do I solve this mess? Well, all I'm going to do, remember, these are just fractions. This is sort of like 50 grams over 1, if you want to think of it that way. All I'm going to do is multiply across the top, multiply across the bottom, and then divide. So I'm going to multiply 50 times 6.02 times 10 to the 23rd. All right, let's do that. So 50 times 6.02. Now I have an exponential button. You're going to use that second EE button. 23rd. Equals. That's what that comes out to be. And then I'm going to divide it by 1 times 27 times 1, or just divide it by 27. 27. And that gives me this ridiculously long number. Now, I don't want to use all of those digits. That'd take me forever to write. So I'm just going to take about the first three, 1, 1, 1, and then the rest are all zeros. Well, how many decimal places are there? Well, that's 3, 6, 9, 12, 15, 18, 21, 22, 23, 24. Your calculator is nice because it automatically gives it to you in scientific notation. I had to count over decimal places, but I get the same thing. Okay? 1.11 times 10 to the 24th atoms. All right, so I multiplied all the tops, and then I divided by the product of the denominators, and that gives me my answer. And I usually take about 3 digits. That's usually good enough for what we're doing. Try to make it 3 digits or so if you can. Okay, well, let's try one more. Let's say we want to know what is the volume at STP. There's a keyword, right? STP is what we know that means something to us. Now, what is the volume at STP of 5.00 grams of carbon dioxide, CO2? All right. Now, I don't see the word moles in here at all, which means this is going to be a 2-step problem. That means it's going to require more than just one step. It's going to require a couple of conversion factors in there. And I'm going to put the thing that I'm starting with, 5 grams, I'm going to put that right over here, right away. And I'm also going to put grams down here because I know that I'm trying to cancel it. Okay, well, what conversion factor, what relationship do I know involves grams? That would be molar mass. We have to find the molar mass of CO2. Let's do that. Molar mass of CO2. Okay, well, what's in there? We've got 1 carbon. That's 12.0 grams. And we have 2 oxygens. That's 2 times 16. That's 32 grams. 32.4 grams. That's 44.0 grams. That's our molar mass. 44.0 grams is the same as 1 mole. That's the mass of 1 mole of CO2. Now, I don't want moles. I want volume. What is volume measured in? This is a gas. Volume is measured in liters. So I have to get rid of moles. I'm going to put moles down here. I'm looking for liters. Well, volume in STP is always the same. 22.4 liters is 1 mole. Notice how I put moles on the bottom so that it would cancel out and leave me with liters up here, which is what I want. I want my answer to be in liters. So now what am I going to do? I'm going to do 5 times 1 times 22.4, just 5 times 22.4. 5 times 22.4. That's 112. Divided by 44 times 1. Divided by 44. 2.54, and so on. Okay, so 2.55. We'll just use 2.55. Equals 2.55 what? Well, the only unit that's not canceled out is liters, so that must be what it is of CO2. 2.55 liters of CO2. So that's how you do the 2-step problems. Start with the number you're given in the problem. Your first step is going to go to moles, so this is just like in the other 2 videos, right? But then you're going to continue on, cancel moles out, put moles down the bottom, and go to the unit that you're trying to find. Go back to the first diagram I drew and draw that in your notes because it'll help you figure out what you need to use. It's not that difficult as long as you keep yourself organized.